Hello everyone, my name is George Hernandez and this is a tutorial for a GUI that calculates the steady state pressure heads and the flow pattern for given boundary conditions. This GUI will utilize inputs such as a hydrodynamic dispersion, time intervals, the time of interest, the porosity, and it will require Qx and Qy, which are Darcy's velocities, used to compute the actual x and y component velocities. The output, once complete, will be an Excel file in which the single file will have multiple tabs. Each tab will include the boundary conditions, pressure heads, x and y final velocities, and the concentration at the time of interest. Some background behind Project 2. It will take inputs, as I said earlier, from the GUI. And these inputs are right here. We'll visit those in a minute. The x and y velocities, component velocities, will be computed by the Qx and Qy from ProjectP1. The ProjectP1.m file is very important for this Project 2 GUI because it will develop all the solved heads, pressure heads, which will also result in the required Qx and Q values. One thing to note is that for this particular Project 2 GUI, it will incorporate all of the information from Project P1, so we should be able to solve everything without having to open two different GUIs. Everything is embedded into one. Currently our method of to solve for our concentrations, we will be using the A/C / method to solve, because it is a much more efficient way to do so. The method would be right here. So this is just a temporary method just to be able to demonstrate how it works. However, the alternative is this method down here, which resembles the LU decomposition format, in which it converts the large A matrix into an upper triangle format and then solves backwards. However, like I said, due to time restraints, it would be much quicker to use the backslash. So we will go ahead and get started here. Step 1 is going to be same as Project 1 to load. We're going to load our data. Now these buttons here, we'll start with the first one where which is to upload the boundary conditions. So first we load our boundary conditions for the heads. Next we upload the pressure head constants. Once we're done with that, for that button, we go on to it'll unlock next, which will be our concentrations button. Within this button, we're going to upload our boundary conditions for the concentrations. Then we will upload our initial concentrations file. In total, there are going to be 4 files to upload, and if there's any confusion at the top of the upload file, it'll show you what file you're uploading first. Next, we input our delta x. So for this, we'll use 50. We'll upload the hydraulic conductivity, which we will set to 30. The transmissivity, which we will set to 30. We'll set that to 40. The hydrodynamic dispersion, which we will set to 300. And because we measure things in terms of days, then we will go every half a day or every 12 hours. Kind of let you know what's what here. If you have any confusion, interval of days at which concentration will be evaluated. I need to fix this one. But for here, day at which the concentration evaluation is needed. So we will do in a month's time span, we will do 31 days. Here we take into account the material porosity. This will be the porosity of the material that the fluid is running over. So in this case, we will set a value of 0.6. So once those values are input, we can go ahead and analyze our P heads first, which is just the pressure heads from project 1. And here you can see this gives you an idea of the surface in terms of elevation. These are your delta X and delta Y values. And we start at 0 and work our way up. So next we will analyze the concentration. And it says here, it'll process the selected files from step 1 and 2. Okay, and here we go. So this right here gives us our final overall concentration. And then here, it gives us a visualization, a visual video of the concentration expanding over time. Here you can see that this is a small little hole. Fluid sinks into it. And out here is where a lot of the flow starts. You can see some of the ripples here. And due to the material's porosity, it'll show you how the fluid is expanding. And this is it. Now, because, let's see if we can bring down these tools so we can rotate. There we go. Let's see if I can make adjustments here. Now, after rotating these files, we can see that have the concentration. We can look at it from different modes. We can compare top view. And this figure doesn't show the velocity vectors, however this one does here on this side. And it really just goes on to show you the direction of flow. We can also look at this from a side profile where we're able to take a look at some of the maximum concentrations. Go ahead and bring this out once again. So I can now with this, I'm able to pinpoint some of the different concentration levels with regards to position and the height. Now, even though that this shows you at the bottom, it's projected only at the bottom. When looking at it from the XYZ coordinates, we're able to look at the concentration over this surface. This right here we can utilize to tell us concentration levels at different points. So we can use this to determine a maximum concentration, which should be where the fluid is coming from initially. And then this pretty much concludes a lot of the solving and a lot of the information that's provided here. One other thing that we can do that is done once the calculations are complete, there's a final data set file which is printed in the Excel format, and all of this information must be within the MATLAB folder so that it can easily access it. Now we're going to go ahead and open up this file and take a look at the spreadsheet. It does take some time because it is a large file. Again, all of this was computed because we used the backslash for assistance. If we utilize our manually built LU decomposition format, it would take much longer. So again, for the sake of time, we use this. Now we have our file, and here we can see the matrix, the different files that were uploaded. Down here we have the solved p-heads, final concentrations. We have our boundary conditions with concentrations, our x and our y components, initial concentrations, and our concentrations at the final time. And again, all of these are with respect to the surface and the pressure heads calculated initially from this project. Now, aside from all of this, excuse me for the delay with all this time and uploading the data, but once all of this is uploaded, you can review as you please and do whatever you'd like with the files. And that pretty much sums up everything. Another thing, the command window one other trick, this gives you an elapsed time of two of the different loops that were run, and you can kind of just review that information. This first time is for the time it took to calculate the matrix, to calculate figure 2, which is the final concentration, and this is the time it took to complete, where is it? Time it took to complete the information from axis 1, which is the expansion of the plume through the surface. Again, here's some of the different, well, it will take long, but that pretty much sums up everything. I hope this was useful, and I hope that everything was pretty clear. If there are any questions or concerns, you could leave a message below. Thanks. Bye.